Okay, so we're going to look at the 2008 paper. We're looking at ethanoic acid and sodium hydroxide acid-base titrations. So as well as our W, we are looking at some, and our big M, our grams per litre, we are looking at extra information being in our question. So we are going to start by filling in our table. And remember, we have acid, sorry, I take that back. We have attic and we have basement. So we are looking for, in our basement, something that will have been whole number that will have been measured out using a pipette. So if we look along this line here, we have 25 centimetre cubed portion, and that's going to be 0.1 big M. The ratio from the equation of the thing in the basement is the sodium hydroxide, so the ratio here is going to be a 1. We then look for the attic, and we have these numbers down here. So the rule is that it has to be plus or minus 0.1 centimetre cubed, so it means I have to ignore the 22.9 and I get the average of 22.6 and 22.7, so that's going to give me 22.65. If I read down here, I want to find concentration of ethanoic acid, so this must be my question mark, and my ratio is 1. So now I have to look as well. We said every time we're looking for any extra information. So if I look at extra information, it says up here, it was diluted 25 centimetre cubed to 250. So 25 centimetre cubed into 250, you've got to work out what your dilution factor is, which is 250 divided by 25. So my dilution factor is going to be 10, and I'm going to need that at some point later on. So we are trying to find our big M. So we start here with what's in 1,000 centimetres cubed. When we go down, we divide by 1,000 to find out what's in 1 centimetre cubed. When we go up, we multiply by its titer volume. We use our ratio here at the flat part, and that's going to give us moles in the other titer volume. We're going to go down, we divide by the titer volume to find out what's in 1 centimetre cubed. And again, every time we go up, it's a multiplication, and in this case, it's multiplied by 1,000 to find out what is our big M value. When we're done with that, then we are going to use possibly our mass triangle. So it is going to be moles, it is going to be mass, and it is going to be a molar mass. And we are going to have to find out what information for our diluted vinegar. From the question you can see here, it's going to be in original vinegar. So that's going to be something we're going to have to look for. And we also are going to have to put information as a percent weight per volume. Okay, so percent weight per volume is the same as grams in 100 centimetres cubed. So looking at all our data in here, this here, the 0.1 is our weigh in. And as you know, I always like to start with what does that actually mean. So this means 0.1 moles in 1,000 centimetres cubed. So we starting here, we now have to divide by 1,000. So it's going to be 0.1 divided by 1,000 is going to be equal to 1 by 10 to the minus 4 moles. And that is in a centimetre cubed. So we're at this little point in our W. Our next step then is to multiply by the titer volume, which in this case is multiplying by 25. So when I do that, I get 2.5 by 10 to the minus 3 moles, and that is in 25 centimetres cubed. Okay, from here I use my ratio, and my ratio was 1:1, so it implies I'm going to have 2.5 by 10 to the minus 3 moles in 22.65 centimetres cubed of my ethanoic acid. So we have just now gone from here to here. So now I need to find out what's in 1 centimetre cubed. So I'm going to divide the 2.5 by 10 to the minus 3 by 22.65. And when I do that, I get 1.10 by 10 to the minus 4. And that is in a centimetre cubed. So I'm now after coming down to this point on my W, and then lastly to finish it off we multiply by 1,000. So when I multiply by 1,000 I get 0.110375. Now if I leave my answer like this, it's too many significant figures, so it's going to be a slip, so it would be marked as a 3 take away 1 more than likely, or taken away 1. So I need to work out what are the significant figures in my question. So technically up here in our box, this is 4 significant figures. So 4 significant figures brings me to here. I have a look at the 7 and what does that do? So the 7 will actually make it round up. So I go 0.1104 big M. Okay. The last thing that we've said that we always do is we do our mass triangle. So in our mass triangle, it is going to be moles by molar mass. So we know I have 0.1104 and it's going to be multiplied by molar mass. So I have CH3COOH. And I said again, we have to show all of our workings out. 12, 16, 16 and 1. And when I add all these together, I will get 60. So I multiply this by 60 here, like so. And when I am done, to 4 significant figures, 6.6225. This is my 4th significant figure, but the 5 is going to make it round up. So 6.623 grams in a litre. Now we check back into our question and we look at our annotations. So first thing it asks up here, calculate the number of moles of sodium hydroxide in each 25 centimetre cubed portion. So this becomes C1. And again, we've said if you can't find what it's supposed to be, as long as you've laid it all out, you just leave it alone. The next thing it's asking me up here is the number of moles of ethanoic acid in a centimetre cubed of diluted vinegar. So this was after using our ratio. So this is C part 2. We then move on to D, find the concentration of ethanoic acid in the original vinegar in terms of moles per litre. So over here, this is our diluted vinegar. So to turn this into the concentration in original, I have to multiply it by my dilution factor to find out what's my original concentration. So that is going to be 0.1104 multiplied by 10 is going to be 1.104 big M. I have to do similar for here because this down here is my diluted vinegar. And if I multiply this by 10, I'm going to get 66.23 grams in a litre, and that is now my original. So up here in the lime green, this was going to be D part 1. So I've turned this into a grams per litre, but it's asking me in D part 2 to turn it into a percent weight per volume. So if it's 66.23 grams in a litre, I can take this, divide it by 1,000 and multiply it by 100, or just multiply the 66.23 by 10, but just divide it by 1,000 because it's in a litre and I want it to be left in 100, so multiply by 100. And when I do that, I will get 6.623 grams in 100 centimetres cubed. And to finish that off, 6.623% weight per volume. Final answer for D part 2.